In the shimmering heat of the Nile Valley, where desert winds hum like ancient hymns and sunlight carves gold into every horizon, the story of Egypt's unseen wonders begins not with the towering pyramids that have dominated human imagination for millennia, but with the silent, forgotten brilliance that made those giants possible, a labyrinth of innovations buried beneath the sands and folded into memory like sacred scripture, for long before the world marveled at Giza's gleaming sentinels, Egyptian engineers were shaping a civilization with methods so audacious, so advanced, that even now, with satellite imaging, infrared scanning, and cutting-edge archaeological science, the full magnitude of their ingenuity remains elusive, a tantalizing whisper of genius drifting across time, daring us to follow its trail. And so our journey begins with the foundations literal and symbolic of Egypt's engineering marvels, with the control of the Nile, the divine river that surged and retreated. In rhythmic cycles the Egyptians called the heartbeat of the gods, a force of nature both creator and destroyer, sculptor of soil and arbitrator of life. And it was the mastery of this river not stone that defined the earliest triumphs of Egyptian innovation. In the shadow of pre-dynastic settlements, engineers and laborers harnessed the flood waters through artificial basins, canals, and levees, turning the landscape into a precisely managed machine of agriculture, each embankment shaped like a promise to the future. Each irrigation trench carved with mathematical foresight, forming a network so intricate that Greek historians centuries later would attribute it not to mortal wisdom but to divine instruction, yet the truth was far more human, and far more extraordinary, for Egyptian scribes recorded the stages of the inundation with obsessive precision, using nilometers, stone tubes, shafts, and stepped channels to measure water levels and forecast harvest yields, taxation rates, and even political stability. The river's height deciphered like a coded prophecy, its behavior transformed into a system of predictive engineering unmatched in the ancient world. And from this mastery arose the earliest experiments in surveying, geometry, and construction logistics as teams of specialists harpedonapte, the rope stretchers moved across the floodplains, straightening lines, measuring grids, and recalibrating boundaries erased by the river's annual surge, their methods combining mathematics, astronomy, and practical craftsmanship into a discipline so refined that the rope stretcher's art would become the backbone of monumental architecture for centuries to come. And it is here, in these early operations of earth and water, that the true origins of Egypt's unseen wonders take shape, for every hidden chamber, every buried temple, every colossal obelisk begins first as an idea etched into the land itself, a melding of natural cycles and human willpower, a conversation between engineers and the divine forces they sought not to control but to understand, and with each passing dynasty the Egyptians built upon these foundations, elevating irrigation into hydraulic symphonies, transforming quarrying into an exact science, and turning logistical challenges into opportunities for architectural revolution. As the valley's population grew and its rulers, kings who called themselves shepherds of the people, dreamed of structures that could transcend mortality. Indeed, long before Khufu's Great Pyramid pierced the heavens, Egypt was already an empire of innovation, a civilization whose unseen wonders pulsed quietly beneath its agricultural rhythms, whose engineers stood at the threshold of possibilities that would reshape not only their world but our understanding of ancient achievement. and so the stage was set for the meteoric rise of a technological tradition that would culminate in marvels so enduring, so sophisticated, that no empire, no matter how vast, would ever replicate their exact marriage of geometry, labor, cosmology, and ambition, engineering not merely for utility, but for eternity. As Egypt ascended into the brilliance of the Old Kingdom, its rulers, emboldened by divine kingship and fortified by generations of calculated environmental mastery, initiated a new era in which engineering became both a political mandate and a spiritual instrument, a shaping force that bound heaven to earth. And it was in this crucible of ambition that the unseen mechanics of Egypt's most astonishing monuments took form. Not merely the pyramids themselves but the invisible systems that made such colossal undertakings feasible, for behind every block of limestone raised into the air for Khufu, behind every polished casing stone fitted with surgical precision along the Great Pyramid's gleaming flanks, lay a symphony of mathematical planning that scholars still struggle to reconstruct. An interplay of angles, proportions, astronomical alignments, and logistical feats so far beyond the capabilities typically attributed to Bronze Age cultures that modern engineers find themselves compelled to re-evaluate long-held assumptions about ancient labor forces and construction technology. But to understand these marvels we must step inside the grand machinery of pyramid construction, peeling away the romantic myths of slave labor and primitive tools to reveal an empire powered by skilled workers, state-sponsored guilds, rotating labor teams, and a chain of command marked by administrative sophistication unmatched in most ancient civilizations, their tools copper chisels, dolerite pounders, wooden sledges, limestone abraders were simple in appearance but used with a mastery that transformed simplicity into precision, while workers used physics to move blocks weighing several tons across desert plains lubricated by water and organized by principles of weight distribution that modern experiments have repeatedly validated, creating a choreography of manpower that resounded like a heartbeat across the plateau. Within the core of Giza's engineering machine, teams of surveyors aligned the pyramid's base with astonishing accuracy, adjusting for astronomical true north, analyzing the arc of the sun, and devising a grid so exact that the base's four sides deviate less than a tiny fraction of a degree. An achievement so meticulous that it has inspired centuries of speculation, from fringe theories of lost civilizations to formal studies in archaeoastronomy. Yet the unseen marvel is not the pyramid's shape alone, but its internal structure: hidden passageways, relieving chambers, corbelled ceilings, and pressure-distributing blocks arranged like the vertebrae of a colossal stone organism designed to withstand eternity's weight, all conceived within an architectural philosophy that combined geometry, cosmology, and the practical necessity of supporting millions of tons of stone. Still deeper lies the understated genius of quarry logistics, in which stone blocks were extracted, trimmed, and transported with a level of coordination that required administrative offices, supply depots, medical facilities, and a workforce whose daily life is now known through excavated villages such as Deir el-Medina and worker cemeteries at Giza, revealing a society where engineers, artisans, and laborers were not expendable forces but honored participants in a sacred enterprise. And as each pyramid rose, it did not stand alone, for every royal necropolis was part of a larger complex: mortuary temples, causeways, satellite pyramids, boat pits, and astronomical alignments all interlocking to create a landscape that functioned simultaneously as a political statement, religious axis, and technological exhibition, a place where architecture became ritual, and where every hidden chamber and sealed corridor whispered of an engineering legacy tailored for eternity. Thus, the unseen mechanics of Egyptian monumental power lay not only in the stones but in the minds that directed them, in the administrative blueprints carefully inked by scribes, in the astronomical readings taken before dawn, in the mathematical ratios calculated in quiet workshops, and in the seamless cooperation of, beyond the golden silhouette of the pyramids, where tourists tread and cameras click, lies an Egypt far more intricate, far more revolutionary, a civilization whose innovations extended deep into the realms of mechanics, medicine, metallurgy, hydrology, and architectural science, creating an empire engineered not merely to survive but to perpetuate its own identity across dynasties. And it is here, in this vast tapestry of lesser-known wonders, that the true brilliance of ancient Egyptian engineering reveals itself. Consider the sprawling temples of Karnak and Luxor, not as ruins but as once living machines of ceremony, astronomical calculation, and acoustic manipulation, their hypostyle halls forested with columns arranged in patterns that mirrored cosmic order, their alignments calibrated to the solstices so that the rising sun pierced sacred chambers in moments of deliberate illumination, moments when architecture became a conduit between the mortal world and the celestial. Or contemplate the precision of obelisk construction, those towering monoliths carved from single pieces of granite weighing hundreds of tons, quarried from Aswan with stone tools but lifted, transported, and erected with a mastery of leverage and counterweight that has yet to be fully replicated experimentally, their tips gilded in electrum to capture the sun's first light, their surfaces inscribed with hieroglyphic invocations meant to broadcast royal power across the landscape. But the unseen wonders stretch even deeper, into the subterranean networks beneath temples, where concealed shafts, drainage systems, and hidden chambers reveal the Egyptians' grasp of hydraulics and structural stress, and into the labyrinthine tombs of the Valley of the Kings, where ramps, tunnels, and false passages were designed to thwart looters and preserve the sanctity of the afterlife journey. A feat requiring not only engineering but psychological foresight. Beyond architecture, Egyptian innovation expanded into agriculture through the invention of the shaduf, a counterweighted irrigation device that allowed farmers to lift water efficiently, and later the sakiyat, a water wheel powered by animals, enabling steady irrigation even during low Nile years, transforming Egypt into a perpetual agricultural engine while neighboring regions struggled against drought and famine. In the realm of medicine, Egyptian knowledge rivaled the best of the classical world, with papyri detailing surgical procedures, pharmacological recipes, anatomical observations, and an understanding of bone setting, wound treatment, and basic dentistry that demonstrated practical engineering principles applied to the human body, as physicians used tools of copper, bronze, and specialized stone with an efficiency that would echo through Greek and Roman medical traditions. Metallurgy, too, was a domain of innovation, with Egyptians developing techniques for smelting copper and bronze, crafting precision instruments, ceremonial objects, and utilitarian tools. While their glass-making and art they pioneered sparked an industry that blended chemistry with artistry, producing beads, amulets, and vessels that shimmered in palace workshops. even timekeeping itself was revolutionized through the invention of water clocks and shadow clocks, devices that allowed priests and astronomers to measure hours with increasing accuracy, synchronizing rituals with celestial events and advancing the Egyptian understanding of the cosmos. And yet perhaps the most profound unseen wonder lies in Egypt's mastery of organization. For every innovation, whether a canal or a colossal statue, required logistics, record-keeping, labor rotation, and resource allocation that only a deeply centralized and technologically informed state could achieve, creating an empire that functioned like a massive, coordinated machine, its gears turning through scribes' calculations, overseers' orders, engineers' designs, and the coordinated efforts of artisans whose crafts were passed down through generations. Here, in the vast expanse of unseen Egyptian as we step into the final corridors of this expansive journey, the sands of Egypt reveal their most profound truth, that the unseen wonders of ancient engineering were not merely feats of construction but a legacy of ideas, principles, and visionary ambitions that continue to shape our modern world, echoing through the disciplines of architecture, mathematics, astronomy, and civil engineering, and influencing the very notion of how societies organize labor, conceive monumental projects, and preserve cultural identity across time. For Egypt's unseen legacy is not confined to its ruins but embedded in the intellectual DNA of civilizations that followed, from the Greeks who studied Egyptian mathematics and adopted its architectural concepts, to the Romans who marveled at Egyptian hydraulic systems and incorporated similar principles into their aqueducts, to early Islamic scholars who preserved and expanded upon Egyptian medical knowledge, ensuring its survival through centuries of cultural transformation. Yet the modern world, too, owes a debt to Egypt's innovations, from the fundamentals of surveying still used in construction today to the very concept of state-sponsored engineering projects that require centralized planning, logistical foresight, and mathematical sophistication. Principles that bind ancient builders to modern skyscraper architects and civil engineers guiding vast infrastructure networks. But perhaps the most compelling aspect of Egypt's legacy is the sheer endurance of its monuments, structures designed not for decades or centuries but for millennia, crafted to withstand flood, wind, looting, invasion, and the relentless erosion of time, a testament to materials science and design philosophy so advanced that even now we analyze their methods to learn how ancient walls resist heat, how stone blocks expand and contract without cracking, how foundations distribute weight across uneven terrain, and how architectural alignment maintains precision across thousands of years. And as archaeologists continue to unearth hidden chambers with ground-penetrating radar, discover forgotten workshops buried beneath temple precincts, and decode engineering manuals etched into tomb walls, we find ourselves confronted with the humbling realization that Egypt's unseen wonders are far from fully revealed, that beneath every excavated layer lies another innovation waiting to be understood. Another testament to human ingenuity poised to rewrite our assumptions about the ancient world. Thus, the legacy of Egyptian engineering endures not only in its physical structures but in its invitation to wonder, to investigate, to question, and to marvel at the capabilities of a civilization that fused science with spirituality, mathematics with myth, and monumental ambition with meticulous craft, forging an identity so enduring that even in the digital age, with all our technology and knowledge, we stand in awe of stone giants built by hands that believed, with unwavering conviction, that their works would last forever, and so, as the desert winds sweep across the Nile Valley and the shadows of ancient monuments stretch across the sands like memories cast in stone, the story of Egypt's unseen wonders persists not as relics frozen in time but as living echoes of innovation, urging us to look deeper, to explore further, and to recognize that the past is not silent but speaks through every block, every measurement, every hidden chamber we uncover, reminding us that the greatest legacies are those carved not only in stone, but in the unending human quest to build, to understand, and to transcend the boundaries of possibility.